So, lice. We all know them, we all hate them. They're persistent creatures that have been plaguing humanity since its conception. But have you ever wondered where human lice came from in the first place? Probably not. Maybe I'm the only one who cares? Regardless, our lice didn't just pop out of nowhere. Today, I'd like to tell you the story of humanity's lice, because oh boy, what a story it is. It's one of evolution, gorillas, and possible interspecies naughtiness? Oh yeah, this is gonna get wild. Strap in, guys. Welcome to Planet Arthropoda. Just a heads up, this is part 2 of my short series on lice. I'll leave a link to the first video, which focuses more as an introduction to the biology of modern lice, in the description and comments. Watching part 1 isn't necessary to understand this video, but it might give more background to what we're talking about today. Plus, you get to hear me talk about Brazilian waxes in a 100% scientific context. Yep, making my mom proud every day. I'll quickly go over the very basics to get everyone up to speed. Human lice come in 3 flavors. 2 of them, Pediculus humanus capitis, the head lice, and Pediculus humanus corporeus, body lice, are subspecies, while the last, Thyrus pubis, the pubic or crab louse, is its own thing. All 3 lice normally stay in their own regions of the human body, as described by their common names, so it's usually pretty easy to tell them apart. So, how did humans get lice? I don't mean individually, little Timmy has nothing to do with this. How did these insects become humanity's menace, and how did we end up with 3 of them? While I won't go too in-depth on the evolution of Cicodia, the order lice belong to, here, as that could be an entire video on its own, I'll touch on a few highlights. The first lice were non-parasitic, just like modern book and bark lice, and lived around 250 to 266 million years ago. The parasitic lice, clawed Thyroptera, came later at 100 million years ago, but these ones had chewing mouthparts. Early lice may have been chewing on dinosaur hide. Sadly, we have no proof of that. Human lice are members of the group Anopleura, which is defined by their possession of sucking mouthparts. Sucking lice arose towards the end of the Cretaceous period, around the same time placental mammals appeared, 65 to 77 million years ago, and by 25 million years ago, the Cenozoic era, the common ancestor of Pediculus and Thyrus lice was busy terrorizing some poor mammal. Now, us humans, we aren't quite that old. Modern humans have only been walking around for a couple 100,000 years. Other primates have had a much longer history, and these were the ones to pass the joy of lice onto us. Through the lice we have found living on a few of our closest living ape relatives, we have a pretty good idea of the journey lice took to where they are today. So, which apes are we talking here? Pediculus humanus has a cousin partying in the fur of chimpanzees. Its name is Pediculus schaeffi. Meanwhile, our dear pubic louse, Thyrus pubis, has Thyrus gorelliae, the gorilla louse. Yeah, I'ma just let that one sit for a second. Everyone okay? Good, cause I want you to hold on to those thoughts for a moment. Now, we do share a common ancestor with both chimps and gorillas. In science, a common ancestor is the species that gave rise to all of its descendants. For us apes, it was a primate that lived 8 to 6 million years ago. For whatever reason, populations of that species split off and did their own evolutionary thing, eventually leading to the apes we see today. Our best estimate says that the gorilla and chimpanzee lineages split around 7 million years ago. Later, around 6 million years ago, chimps and humans split up too. It's important that I make this very clear. From here on, unless I'm explicitly talking about modern times, I am not referring to modern animals when I say humans, chimps, or gorillas. Real evolution is not what we see in Pokemon. There were many in-between steps before us, and these middle stages are what I am referring to here. But since we're still unlocking the secrets to primate evolution, I'm just going to use the modern names, as did the papers I read for this research. I hope you will understand. Logically, the Great Lice Exchange would have happened near these dates, but humans have got two genera of lice. Gorillas and chimps have one apiece. So why are humans the lucky ones with both pediculus and thyrus lice? Scientists have two ideas. To quote David Reed, pair of lice lost or parasites regained? In the lice lost hypothesis, that common ancestor would have had both genera of lice, while Reed retained both. Chimps and gorillas lost one of the two sometime during evolution. Parasites regained assumes our lice speciated, or developed in a new species, alongside us apes. Under this hypothesis, pediculus and thyrus lice diverged along with gorilla and chimp lineages. Pediculus diverged into its species when humans split from chimps. Then gorillas gave humans crabs later on, somehow. Hold on to those thoughts, folks. Multiple studies have attempted to unravel the phylogenetic, fancy word for the study of evolutionary development, relationships between these lice genera. So far, the consensus seems to be that the pediculus lice indeed split up near when humans and chimps diverged, 5.5 million years ago, while thyrus lice held off until around 3 million years ago, way after gorillas diverged from the rest of us. This supports the parasites regained hypothesis, and most of the material reviewed for this video leans that way as well. We're talking about a huge amount of time here, though. Time that we don't necessarily have a flawless fossil record of. As such, new evidence could emerge to turn opinions in a different way. For now, we will leave it at that. Now that we've sorted out the when, it's time to talk about how humans got our lice. With pediculus lice, the answer is pretty simple. Both chimp and human lineages would have started with the same lice species. As ancient humans became more human and chimps became more chimp, their lice each became more suited for their bodies. Eventually, chimp lice adapted so much for life on chimps that they couldn't really go back to living on humans, nor could they mate with human lice, who had adapted the same way. They were officially separate species then. Yay! Well, if that's where P. humanus came from, then what about its subspecies? P. schaeffi is boring and doesn't have subspecies. Why did P. humanus have to be special? To answer this, we must first ask a question humans have had for a millennia. Why are we naked? No, seriously, why? In comparison to other primates, humans have shockingly bare bodies. We actually have about the same density of hair follicles as others do, but most of our hair is fine and leaves the skin exposed. Why is that? We can look at the naked ape problem from many angles. Early humanity was living it up on the hot savanna, so the easy guess is that our nakedness began as an adaptation to keep us cool. Wouldn't you rather be naked than swaddled in fur on a hot summer's day? Thing is, hair also plays a crucial role in protecting skin from sun damage. Other naked animals who live on the savanna, like elephants and hippos, protect themselves from UV radiation in other ways. Mud baths, hiding underwater, nocturnal activity. Since humans aren't naturally inclined to protect ourselves in these ways, though playing in mud is awesome, losing our natural UV protection seems really counterintuitive. Plus, even on the savanna, it can get chilly at night. We obviously didn't stay put in warm environments either, so selection for fur probably would have been helpful. So what gives? While we're still not 100% sure, one idea blames lice for human nakedness. Lice, mites, and ticks are what's known as ectoparasites. They feed on or through their host's skin and sometimes spend their entire lives on that host. Since most animals don't like having bugs biting them, ectoparasites make it difficult for hosts to dislodge them, often by hiding. What's more hidden than in fur or feathers? Hairy primates are awesome hosts for ectoparasites. Heck, one of the most stereotypical primate things to do is to sit around picking the things out of each other's fur. Social grooming is widespread in primates, and though it is important for reinforcing social group bonds, the behavior is critical for removing ectoparasites in hard-to-reach areas. Humans are not exempt from grooming. Even outside of the industry we've built around hairdressing, us humans just really like playing around with hair. Brushing it, braiding it, picking out parasites, lice combs, anyone? We don't really eat the bugs we pick out like other primates do, generally. Hey, I'm not judging. What else are they gonna do with those tasty ticks? Bit of a waste to throw them out, really. Anyways, while humans do groom one another, we spend a lot less time doing so than we would if we were hairier. And that, my friends, is the proposed benefit of nakedness. Back when we weren't naked, those born with reduced body hair who could spend less time and energy grooming may have had an advantage to hairier early man. More time to focus on hunting and stuff, you know? These early streakers outcompeted the hairy prudes, so the genes promoting nakedness became more prevalent. Over time, the human population became more and more naked, and eventually we got to where we are today, with dense hair regulated to our heads, armpits, and genital regions. Unless you're my uncle, I swear that man is Bigfoot. Again, this is only a theory. If it is true, though, wouldn't it be remarkable to trace our nakedness back to some tiny bugs? It certainly gives me a new appreciation for them. Though that still doesn't answer the question of why we've got both head and body lice. Other apes basically have whole body head lice, just by virtue of being covered in hair, but most humans really don't have that excuse. Since we are naked, doesn't the existence of body lice sort of invalidate the whole naked as an evolutionary adaptation to ectoparasites thing? Nope. In humanity's hairy days, our pediculous lice were free to roam our bodies as they pleased. As the hair suitable for lice claws receded, they gradually became restricted to our heads. Then, something weird happened. We got our fur back. Not literally, but if there's one thing the human race is good at, it's improvisation. At some point, we decided that having our naked butts exposed to the wind was not okay. So, logically, we took the pelts off of the animals we'd hunted for food and wore them for protection. Behold, clothes. Humans likely began wearing clothes around 100,000 years ago. They weren't anything fancy, but they did the job. What clothes also did was give a layer of cover for lice to hide in. Suddenly, pediculous lice weren't restricted to the scalp. Sure, they preferred the nice hair that the tasty human couldn't easily remove, but falling off the head wasn't guaranteed death from exposure anymore. Eventually, some lice lived in clothes for so long that their morphology changed to favor that lifestyle. Thus, the body louse was born. If you want proof that this transfer is plausible, consider this. In part 1, I talked about a little experiment testing the genetics of Pediculus humanus subspecies. Though they do have morphological differences, head and body lice are normally told apart based on the area of the body they're found in. Scientists knew that they could breed with one another, and this made them wonder if the lice would adapt on their own if forced to live in areas atypical for their subspecies. Head lice were strapped to arms and body lice to the scalp for feeding, with both populations observed for several generations. I am sure the research subjects were thrilled. While the body lice didn't change, it only took 5 to 6 generations for the head lice population to become indistinguishable from body lice. Genetic differences would likely take longer to fully take shape, but considering that female head lice only live around 30 days and can produce thousands of eggs in that time, the development of a viable subspecies would happen fairly quickly in the wild. An entirely new niche opening up on the human body was the perfect opportunity for this. Okay. I've put it off long enough. Time to get back to those gorilla crabs. I'll be honest, they're the entire reason I started this series. I just happened to read that the pubic louse's closest relative is the gorilla louse, and how could I let that one go? Now, I know we're all thinking it, but a King Kong scenario, credit to Robin A. Weiss for that one, might not be how humans got them. We obviously can't ask the gorillas or lice for their deep, dark family secrets, but there are other possibilities. Folks, you don't have to have sex with someone to get their crabs. Sharing a sleeping space is enough for human pubic lice. If human ancestors, say, took a nap in a discarded gorilla nest, that'd do it. Heck, you don't even have to have sex with someone to get other STIs, even interspecially. Take HIV, human immunodeficiency virus, for example. There is a similar virus found in chimpanzees called simian immunodeficiency virus, SIV. Somehow humans caught it, probably by hunting chimps for bushmeat, and though SIV in humans is pretty harmless, viruses have a pesky habit of evolving into more powerful strains. We've all become familiar with that in the past few years, haven't we? So we caught HIV from chimps. Multiple times, actually. I guess people really like chimp meat. Pathogen exchange happens a lot with primates, which is why you'll sometimes hear concern that tourists will transmit disease to protected primate populations. As much as us humans like to pretend we're unique, we're so genetically similar to our fellow primates that diseases spread easily between us all. Lice really wouldn't be that remarkable. To add to this, for gorillas, thyris lice aren't exactly pubic lice. Just look at this picture of a gorilla. Admire its hair. It's thick, coarse hair, spread all over that muscular body. That's the kind of hair crabs love. Humans mostly have hair like this around our groins. Surprisingly, while humans are the naked apes, we're pretty much the only primates with pubic hair like this. Sure, gorillas and stuff have hair there, but it isn't as prominent as ours. I don't think YouTube would like me showing pictures for proof. Plus, my FBI agent is really asking questions after this research. So if you're really curious, go check out some primate documentaries and check out our relatives. We're not sure why humans developed pubic hair in the first place, but it's thought to be a signal of reproductive availability and a method of scent dispersal. I know, it's gross, but we're animals. We're all gross. Point is, thyris lice crawl everywhere on gorillas. Their transfer to humans was very likely something less scandalous than gorilla sexy time, but that doesn't make it any less interesting from an anthropological perspective. How much interaction did we have with early gorillas? Did we really hunt them for food? Did they hunt us? Did we have sexy times? Maybe it wasn't weird back then. I don't know, I'm just a person with an unhealthy fascination with bugs. While the evolution of human lice still holds many mysteries, they have revealed many truths and possibilities hidden in our ancestry. Further discoveries may reveal even more surprising and spicy details. And I, for one, am all for that. I admit, I don't particularly like humans. Our species is gross, period. But I do like learning about our history. If lice are the way to go in unlocking our past, then I'm all in. Let's decode history together. Okay, I'm done with the lice. For real this time. Are you still itchy? I think I managed to cure myself of lice-induced itchiness by creating these videos. It's great. The new culprit is bedbugs. Ugh. Let's all look at fish now. Thanks for exploring Planet Arthropoda with me. Any questions, comments, or concerns? Have any questions about arthropods in general? Leave them in the comments below. Subscribe to explore the wonderful world of our arthropod overlords with me. Until next time, peace. Stay away from gorillas.